But in the end, we'll look at this map. So a little bit of background. My name is Ian Schneider. I work for a company named OpenGeo. We are members of the OpenGeo Spatial Consortium. So part of that is implementing standards. Is everyone familiar with the standard of WMS?
Yep.
So what I want to talk about tonight is an interesting aspect of WMS, as well as something to consider for anyone who's managing data. So this project that I work on is, I'm actually like the tech lead for this. We do a fair amount of development. It's called mapstory.org. The client is a not-for-profit, MapStory Foundation, but the idea is to be a global commons for telling stories which deal with temporal aspects of your data. So in this example, which I'll get to, I found some data online at the state level, Colorado. It happened to be drilling permits, and luckily, it had attributed data about when these permits were created. And this is really important because if you want to animate your spatial data over time, it becomes really, it's really imperative to have it indexed in your database. So probably a lot of you have seen spatial data in the past. You'd see something like, DC area murders 2010, right? Maybe that's the name of your layer. And then you have DC area murders 2011. Well, what if you want to do like something that crosses year boundaries? Like you want to analyze, maybe murders are really bad between like, I don't know, November and March, as opposed to some place that lies between a year. Well, that makes it tougher when you have your data structured in such a way that it's actually in separate physical layers. The other approach, which I often see, is that you put it into columns. So the data is actually encoded into a column. So you'd have population 2010, population 2011, population 2012. And that's nice because you save on geometries, right? So you have a single geometry, which might represent your state or county or whatever, that's pretty static, and the attributes data is changing through your columns. But now try to make that actually work at scale with a database operation where you're indexing date and time, but using a column in direction level, fail. So my little, open data plea for everyone is that if you manage data, please encode a time onto your attributes. It might be a start time, it might be an end time. Sometimes attributes come in, or features come in and out of existence. Make multiple entries. You have a duplicated geometry, but at least you've captured that important temporal aspect of your data. I was quite disappointed when I went to find some data for MapStory. I went to the City of Fort Collins website. Sorry if anyone heard from the City of Fort Collins, but the natural area spaces had no temporal encoding on them. So all the natural areas were there as they exist now in 2012, but there was no indication of when they started, when planning started, nothing. So think about time with respect to your spatial data because it's an important dimension. So how does this relate to WMS? One of the aspects of WMS is that it offers a transparent way to slice into your data using any dimension. Time and elevation are specifically supported, but the idea is that you can make a request and let's say your data set is drilling permits in Colorado. The client can transparently make a request without knowing the interior details of the data. When is the start or end date of that feature's existence? Because the WMS spec says you just add a time attribute, and you can encode that as an instant, let's say 2012 or 2012 March, or you can encode it as a range. But the idea is that if your service has implemented the specification, then your client does not have to understand the details internally of your data. So it can simply make requests that say, this is the time dimension that I'm interested in. Why is this interesting? Because it also applies to other dimensions. The Weather Service, NOAA, for instance, they have multi-dimensional data. Not only is it X, Y, and T, but it's also E. So you have, a lat, long, a time element, and then you also have an elevation element because so many of their forecast models are actually at various heights in the atmosphere. So if you can transparently slice into data through attribute agnostic API, then you can write a generic client that can look at multi-dimensional data and pan through it. So real quickly, I don't know what my time is, but some people moving 20 seconds. So this is my little icon up there. I'm not wearing glasses, but so you know, MapStory right now accepts basically CSV and shapefile data. It's encoded with time. I grabbed this data set off of this is Escape. I attributed it down here in the abstract, but sorry, COGCC. So this is basically representing all the permitting information that has occurred. 5,000 different well permits for oil drilling over, I think, 2011 to 2012. And then basically the client is asked for the range of dimensions from the server, and then it's basically